Welcome to Spaceverse, your portal to cosmic adventures. James Webb Space Telescope images reveal stunning new dimensions to the universe that extend well beyond the Big Bang. Some scientists are proposing that we may have found evidence of a cosmos that existed before the Big Bang, based on recent groundbreaking discoveries. Dr. Roger Penrose, a scientist who recently earned the Nobel Prize, proposed the theory that if we delve deeper into the Big Bang, we would be able to observe a world that existed before it. He suggests that the Big Bang was smooth and eerie like a limit, and that the universe may have continued to expand beyond that point. If you look back to the Big Bang, you'll find that the inflationary phase occurred before the explosion, not after it. New evidence from the Webb telescope suggests that the Big Bang was not the starting point for everything. Get ready to be amazed, for the Webb telescope has discovered a discovery that will change the world as we know it. Astronomers discovered that the universe is expanding in 1921 by observing the movement of galaxies. However, the expansion of the universe is not as straightforward as it may seem. To help you understand, here is a straightforward analogy. Imagine a piece of paper that is completely blank and goes on forever in every direction. You could consider this sheet to be the fabric of space. The scientific phrase for the stretching and growth of this fabric of space is the expansion of the cosmos. Imagine two galaxies located in this expanding region to help you grasp how cosmic expansion works. As space expands, you can observe that the galaxies are moving away from each other. Even though it may seem that this expansion is happening from a fixed point in the middle, it is not actually what is happening. We ought to relocate the third galaxy to another section of the manuscript. As you can see, all three galaxies are moving away from each other. It seems that there is no single central spot from which the expansion starts. In fact, no matter where you are in the universe, you will always see yourself as the center of everything, because everything else will seem to be moving away from you. Every point in space is expanding because that is how growth operates. Scientific investigations show that the farther away a galaxy is from Earth, the quicker it seems to be moving away from us. This indicates that the universe is expanding more quickly than it has in the past. This would suggest that the perceived speed of light increases by 70 kilometers per second for every 3.26 million light-years beyond Earth. Researchers have shown that at a certain distance from Earth, the expansion of space is faster than the speed of light. When we consider Earth to be the center of the galaxy, this becomes more understandable. Galaxies are moving across the expanding universe at a speed that is faster than light outside of that area. There is no reason to worry because the well-known rule that nothing can travel faster than light is not broken in this situation. It is not the space itself that is subject to Einstein's law. It is the objects that are moving through space that are susceptible to it. From the perspective of physics, it is very reasonable that space is expanding at a rate that is faster than the speed of light. All of humanity's astronomical observations from centuries-old observatories are contained in the Hubble sphere, a region with a diameter of about 48 billion light-years. This region of space is where all of the most distant galaxies that have been discovered to date are located. In this area, galaxies are still moving away from Earth, but they are doing so at a slower speed than light, which allows some of their light to reach Earth. Light from distant galaxies started traveling toward Earth billions of years ago and will eventually reach our planet. Consequently, as the Hubble sphere continues to expand, our capacity to observe more distant regions of space will improve. The expansion of the Hubble sphere will eventually reach a limit. The reason for this is that galaxies are moving away from us at such a high speed that the light we emit will never be able to reach them, save for a certain area in space. As a result, there is a limit to the distance that Earthlings can see in the universe. The observable universe is the area that is located beyond this background. It has a diameter of about 93 billion light-years. The precise dimensions of the universe are still unknown, despite the fact that scientists have observed a significant amount of space outside the observable universe. The vast majority of scientists may consider infinite space to be the working hypothesis. Another conundrum has appeared, adding to the mystery of our universe. Seeing at the distant parts of the universe is like seeing through a time machine. Instead of viewing those areas as they are today, we see them through the lens of their historical development. Because light moves through space at a constant speed, this effect happens. For example, when we look at an object that is 1 light year away, it looks to us just like it did a year ago. The further back in time we can see is determined on how deeply we look. Astronomers have been able to see things that are almost 13 billion light years away in the early universe by using gigantic telescopes. Astronomers have been able to create a standard model of the universe because of these discoveries. This model illustrates the condition of the universe at different points in time. For instance, the dark ages can be observed from a distance of more than 13 billion light years. This implies that at this moment in time, hydrogen gas clouds were present over the entire universe. According to the standard cosmological model, if someone were able to look back in time to the beginning of our universe, which is known as the Big Bang, they would be able to see it from a distance of 13.8 billion light years, which is the farthest point in our observable universe. The scientific community agrees that the universe began as a singularity, which is a single point that is exceedingly small. We will never know the exact shape of this singularity because our current scientific theories do not provide an explanation for it. Just as our ability to sense space is limited by the boundary of the observable universe, our ability to experience time beyond the Big Bang is likewise severely limited. Scientists believe that the Big Bang marks the end of the universe. Our fundamental understanding of the universe, which is built on decades of observations and theories, is what we know thus far. However, recent discoveries made by the James Webb Telescope have revealed that the Big Bang is not, in fact, the genesis of existence. Long before the Big Bang, there was a strange universe, and new findings from the Webb Telescope provide significant support for this perspective. The James Webb Space Telescope took this amazing picture, which is truly remarkable. The light from a supernova explosion that took place 10.2 billion light years away may be seen. This image is made even more interesting by the fact that the same supernova appears in 3 different places at the same time. This is due to a phenomenon called gravitational lensing. Scientists are studying this supernova to determine how fast the universe is expanding. Supernovae are a terrific tool for this since they show us how the cosmos has expanded throughout time. On the other hand, recent estimations that are based on this supernova suggest that the universe is expanding faster than anticipated. This new measurement is unexpected since it indicates that the universe may have started to expand before the Big Bang occurred. This notion is also supported by Dr. Roger Penrose, a Nobel Prize winner who believes that the expansion of space began before the Big Bang. He claims that the inflationary hypothesis states that you experience this inflation right after the Big Bang. No, I'm saying that it was around before the Big Bang happened. I contend that this rapid expansion is the only reasonable explanation for the post-Big Bang effects that appear to be growing exponentially. When you look back to the Big Bang, you will find that the inflationary period happened before the explosion, not after it. This discovery adds to the increasing amount of evidence that suggests the universe existed before the Big Bang. A large amount of evidence has been collected by scientists that supports this notion. The James Webb Space Telescope has been used to discover galaxies that are far away. Many of the characteristics of these galaxies do not match the predictions made by Big Bang theorists. In particular, the galaxies seem to be farther away, larger, older, more ordered, more metallic, and more abundant than what is predicted by orthodox secular cosmologies. One of the most surprising discoveries made by the Webb telescope was the detection of a burst of light that originated from a time in the universe's history known as the Dark Ages. According to the current cosmological model, humans will not be able to observe anything that occurs after this time period. However, Webb's discoveries go against this idea, which has led cosmologists to reconsider a number of beliefs that they have held for a long time. The James Webb Telescope is uncovering odd events that happened close to the Big Bang. These findings suggest that the Big Bang may not have been the very first event in the history of the universe. The discovery of strange relics that date back to a few 100 million years after the Big Bang indicates that the universe may have existed before this event took place. The James Webb Telescope recently discovered 3 galaxies. Of all the galaxies that are known, JWST 14-0 is one of the farthest away. This galaxy was not discovered until 290 million years after the Big Bang. Scientists are puzzled at how nature could have created such a massive, bright galaxy in less than 300 million years. In addition, they claim that scientists will definitely find many more bright galaxies with the Webb telescope in the next 10 years, and possibly much sooner in the cosmos. Scientists now realize that some galaxies in the early universe evolved at a rate that is quicker than what we currently believe is possible, according to these discoveries. That theory suggests that some of these primordial cosmic objects are extremely large. They have too many stars in them. It is impossible to reach that level of massiveness in the time that has been given. It doesn't make sense that all of the common things in the universe would have been put into them. The universe does not contain enough common matter to produce such a large number of stars. The Big Bang Theory, a cornerstone of modern cosmology for decades, serves as the foundation of our understanding of the universe's origins and evolution. According to this widely accepted model, the universe began as a singular, immensely hot and dense point around 13.8 billion years ago, rapidly expanding and giving rise to the cosmos as we know it. However, recent advancements in observational astronomy, particularly findings from the James Webb Space Telescope, JWST, are prompting some scientists to reconsider aspects of this well-established theory. The Webb telescope, with its unprecedented ability to peer into the distant past, has provided a wealth of data that challenges certain assumptions tied to the Big Bang model. Specifically, its observations of distant galaxies and other early universe phenomena raise questions about the conventional idea that nothing existed before the Big Bang. For years, the Big Bang was considered the absolute beginning of time and space, with no preceding conditions or entities. However, some of the newly detected structures and behaviors in the universe suggest a more complex prelude to the Big Bang, or alternative mechanisms shaping its aftermath. These revelations have sparked debates within the scientific community, with some researchers arguing that the Big Bang theory may require significant updates or even an entirely new framework to accommodate the latest evidence. As the Webb telescope continues its mission, it is expected to further challenge long-standing ideas and potentially reshape our understanding of how the universe came into existence. Certain evidence suggests that the universe may have been in a different form prior to the Big Bang. Dr. Roger Penrose, a Nobel Prize winner in physics, is one of the well-known experts that support this idea. He proposed a notion that states that the universe existed for a long period before the Big Bang. In a recent interview, Dr. Penrose stated that we can think of the universe spreading beyond the Big Bang. He referenced a famous piece of art by Dutch artist M.T. Escher that shows angels and demons as an interesting example of his argument. He made the observation that you can represent infinity in this picture. It is an excellent representation. You are showing an endless distance, but it feels like a finite one. I completely agree. Although the artwork seems to show a limited distance, the truth is that the devils and angels continue to travel forever. This type of geometry is referred to as hyperbolic geometry. Infinity is represented in a lovely way. I think that picture is really important when it comes to spacetime. The Escher bounds were comparable to the Big Bang. However, you may see yourself taking this cosmos beyond that area because it is beautiful and smooth. This circular barrier indicates the end of the Escher artwork, yet one may still imagine spacetime continuing to grow beyond it. If you want, you can step outside of it. The issue is that celestial beings, like as angels and demons, adhere to the distance measure and hence are unable to cross it. As a result, they have a grasp of the idea of distance. Photons, on the other hand, can exit the body. These groundbreaking discoveries suggest that the Big Bang may not have been the beginning of everything, but rather a chapter in a much larger cosmic story. The idea that other universes or cosmic events might have preceded the Big Bang introduces a revolutionary perspective on the nature of reality. If this hypothesis is confirmed, it would challenge one of the most fundamental assumptions in modern cosmology, that the universe began as a singular event and that time, space, and matter originated from that point. Such a confirmation would force scientists to rethink not only the origins of our universe, but also the broader mechanisms driving cosmic evolution. It could open the door to theories involving a multiverse, cyclic universes, or other frameworks that propose an eternal or recurrent cosmos. These concepts, once relegated to the realm of speculative physics, could gain significant traction and demand rigorous exploration. The implications of this shift in understanding would be profound, extending far beyond the scientific community. It would transform how humanity perceives its place in the cosmos, altering our philosophical and existential outlook. Instead of a singular origin story, we might find ourselves as part of a much larger, interconnected tapestry of existence, with the Big Bang as just one note in a cosmic symphony. Such a paradigm shift would mark a major milestone in our quest to understand the universe and our place within it. Thanks for watching. If this mind-blowing topic got you excited, make sure to like, subscribe, and tap that notification bell so you're always up to date with the latest cosmic revelations from Spaceverse.